to repeat something that was said in a William Husband video. This is a death cable. Danger noodle is what I've been told to call it before. Don't do this. I understand electricity. I know that 120 can and will eventually kill me during this. So you should. I need a 120 outlet because I did the calculations, and hot dog's around 500 ohms. With 120 AC, that should give us around like 800 milliamps, which will be pretty good to control and cook it. It's not going to be pulling any crazy numbers of current, so I will be able to put it into a wall outlet and not have to worry. Relatively, I'm doing this in a relatively safe way. I am going to be plugging the actual end of this into a surge protector, so that way if anything does happen that's crazy, it'll pop a fuse in the surge protector, hopefully stopping me from continually holding onto it and dying. So yeah, I separated the wires at this part so that way I can attach them to my relay that I have and wire this in to the Arduino. So I just ordered these relays. This is my first time using them. Right now I have my multimeter set to continuity. So as soon as those two connections are connected, it'll beep. So let's try and figure out how to make this work. And we'll test out ground and N1. So now, first test. No. Okay, now is the correct answer. What I should have done from the get-go, this right here, VCC, all that really means is actual voltage input as far as I'm concerned. What it does normally with this jumper installed is the VCC goes through the jumper to the relay and it gates the relay to where it's shut. Really cool. Now the common line, which is normally going to be the side that has power on it, is going to provide power to that normally open side. The thing that I was trying to do was have ground go to ground on the Arduino, have input 1 be the input voltage. The reason it didn't work is because when I put on the signal, which is 5 volts, and it goes through input 1, it goes to the opto isolator, goes through the resistor, and back to VCC. That doesn't do anything. It does not work. All it does is make it so this opto isolator creates a path for voltage to go down from VCC. But because I had nothing on VCC, nothing actually happened. It never once touched the relay. What I should have done was had ground to ground like I was supposed to, constant 5 volts on VCC, and a signal on input 1. I had it coded to where when I wanted the relay to be shut and therefore allow power to go through to the hot dog cooker, it would turn on the 5 volts. I should have done the opposite because without input 1 having any voltage on it, VCC goes through the jumper, goes through the relay, and shuts the relay. Goes through the transistor and back to ground. With input 1 on, VCC, or input 1 on, the opto isolator is gated on. VCC will go down instead of through here, through the opto isolator, through the transistor to ground. Very cool and very smart of me to not do that. So I had to change the code. I had 5 volts going in here at all times. When I didn't want it to provide power to the terminals of the hot dog, I have it to where input 1 is gated on, and when I do want it, I just turn input 1 off. It's pretty simple. I just changed a high from a low in the code. All right, cool. Okay. So I figured out how to fix the relay. I had to change my code a little bit. As soon as I press the button, click, and it starts outputting the voltage. I also had to code in for the LED, the red one. At first I was just going to have it in series with the signal, but that doesn't work because the signal's always going, which means that the red danger light would be always on, which if the danger light's always on, that means there's no danger. I recoded this LED so it turns on whenever the relay is turned on, which means that the relay gate signal is off. And yeah, I coded a quick little beep to let people know, hey, it's about to go down, and hands-free. And that's it. As you can see, when the relay is gated on my multimeter, it is shorted. So yeah, that took a lot of learning how to code, and then also on top of that, just studying the schematic of the relay in order to understand why it wasn't working that first time. So here I am, like, actually putting the wiring for the main power onto the little wooden electric chair I made. I just made a little wooden seat with a hole in the middle of it, put a nail on the bottom, and then glued a couple popsicle sticks together to make the little headpiece that'll go on top of it, and super glued all the wires on so that they won't move. This is the actual, I'm going to call it the WID, the wiener interfacing device. So you put your wiener in the hole, fully dock it into the docking spike, then you will lower this wire right here into place to place it into the top of the wiener. That will be called something cool, like, I don't know, I was thinking like sonar or something. So for sonar, they call out soundings, so I'll call this the sounding wire. It'll go into the head, pretty much, of the wiener, and then that will allow it to complete the circuit and start cooking it. And here I am wiring in the main power cable to the relay and putting all of the Arduino parts onto a smaller breadboard just to give it a smaller form factor on it and make it so it isn't as bulky and cumbersome to carry around, and it moves around as one piece. I also moved the LEDs so the LEDs can be not on a breadboard and easily visible, and so that's it. So I rewired it, put it on a smaller breadboard so it'll be able to be put inside of a smaller case. I rewired the LEDs because they both go to the same ground. It doesn't matter if I wire them like this. Tested it real quick. Click, and the relay works. So now it's all ready. I just need to test how long I have to cook the hot dog for, give it a nice pretty look, polish it up a bit, hide some of the ugly bits, like all of it, and then we're good to go.